So this lesson, we're going to deal with what we call polygons. Polygons are shapes that have sides to them. The simplest polygon is a triangle. And then from there, we're just working with like four-sided polygons. So, you probably are familiar with the square and the rectangle, the rhombus, the parallelogram, and then we have the trapezoid. So these are all what we call basic shapes in when working with polygons. So the first thing we talk about is find the perimeter of a polygon, and we're going to use just formulas to do this. So again, a polygon is just going to be shapes that have sides and they have angles. Right now, though, we're just going to be focusing on the sides. So the first thing we have is what's called the perimeter. Perimeter is just the distance around an object. So we have these formulas that we can use to find perimeter. So again, a parallelogram, by definition, opposite sides are parallel. So notice how we have these two sides are the same distance, and these two sides are the same distance. So usually what we have are some different vocabulary. So here they're saying to find the perimeter of a parallelogram, you have twice the base plus twice the s, or 2 times the quantity b plus s. So b is denoted as the base, and s is denoted as the adjacent side. But the bottom line is, to find the perimeter, all you have to do is add all four sides up. And since there's two b's, that's 2b. And since there's two s's, we have 2s. You're probably more familiar with the rectangle, L and W. So to find the perimeter of a rectangle by formula, we just got to double the length and add to that double the width. Or we can also go 2 times length plus width. So there's a couple options there to find the perimeter of a rectangle. A square, we usually denote S as the sides. So 4 times S would be the perimeter. A rhombus is very similar to a square. The catch is, in a square, we have 4 right angles. The angles on a rhombus, just like a parallelogram, are flexible. They're not locked in. So a rectangle and a square, the angles are all right angles, but in a rhombus and a parallelogram, those angles can fluctuate. But the bottom line is, in a rhombus, though, all 4 sides have to be the same length. So to find the perimeter, that's just going to be 4s. A trapezoid, by definition, 2 sides are parallel and the other 2 sides are not. But we close it all together to make a 4-sided shape. So the parallel sides are usually denoted as B1 and B2, so base 1 and base 2. And then A and C are just considered the other 2 sides of the trapezoid. So to find the perimeter of a trapezoid, we just add all 4 sides together, B1, B2, A plus C. To find the perimeter of a triangle, we usually denote the 3 sides of a triangle as A, B, and C. So A plus B plus C would be the perimeter of a triangle. So those are our basic formulas. So again, a trapezoid is one of those unusual shapes. So again, a trapezoid is a 4-sided polygon, but again, it only has 2 parallel sides. So keep that in mind. It only has 2 parallel sides. Now, a parallelogram has 2 pairs of parallel sides. So if you look at the shapes, a trapezoid could take on different looks. As long as the B1 and B2 are parallel, how you connect A and C can vary. So the parallelogram can kind of get distorted. And also how the bases can also be parallel vertically. They can be parallel horizontally, and it can be parallel vertically. So remember, with shapes, they can be rotated around. So they're not locked in. So they can be flipped around, twisted around, moved around until they're in a shape that you can kind of relate to. So let's look at our first example. The rear window of a pickup truck is a trapezoid whose shorter base is 40 inches, whose longer base is 48 inches, and whose non-parallel sides are 16 inches each. How many inches of rubber gasket are needed to surround the window? Notice how it said surround the window. That's an indication that this is a perimeter problem. So really, the boils down to is we just add the four sides together. So our formula is going to be this B1 plus B2, and then the two sides, the non-parallel sides, would be added together. So we would have like, one of the sides is 40, the other base is 48, and then the two non-parallel sides are going to be the 16 and the 16. So 40 and 48 would be like 88. 16 and 16 would be 32. So we have 88 and 32. So we have 120. I didn't write 120 though. I wrote 200, didn't I? So 120 would be our answer there. So 8 plus 2 was 10, carry the 1. That's 120. And since this is in inches, our unit of measurement would be in inches. So sometimes what we're asked to do with perimeter is we're trying to find the missing dimension of a composite shape. The composite shape is kind of an irregular shape. It's not going to be a normal looking thing, but it's going to be made up of shapes that we're familiar with. So to find a missing dimension of a composite shape, we have to determine how the missing dimension is related to the known dimensions. And then we want to make a calculation of the known dimensions according to the relationship found in our original step there, step 1. So if I want to find the missing dimensions X and Y on the slab foundation, let's see if we can piece this together. So notice how what we can do is we can partition this off into shapes that we're familiar with. Notice how we could create this as two rectangles by drawing a dot line this way here. So if I look at from this perspective, we would say that this is 5 feet 6 inches. Five feet 6 inches. Let me see if I can write inches a little bit better than that. Let's try and make the quotation symbol for inches, but I'll go ahead and abbreviate like they did. And notice how the bottom would have to also be 5 feet 6 inches. And we know this side here is like 8 feet 6 inches, which means this side over here has got to be 8 feet 6 inches altogether. So if we do that this way, what we can pick up on is we know this total distance here is 12 feet 6 inches. So notice how Y would be here, but Y would also be here. So we can kind of pick up on is, the 5 feet 6 inches plus Y would have to add up to the 12 feet 6 inches. So if I write an equation like that, we can solve for Y by subtracting 5 feet 6 inches on both sides. So we would be subtracting 5 feet and 6 inches over here, and we would end up with 7 feet and 0 inches, or in other words, that'd be 7 feet. So Y would be 7 feet. So if we have 7 feet plus 5 feet 6 inches, that would add up to 12 feet 6 inches. Now, if I cut it the other direction, notice how I can find X this way. So X would be kind of more of a vertical distance. So vertically, we know that this is 8 feet 6 inches over here altogether. And we know that since this is 3 feet 6 inches, I could bring that in here like so and say 3 feet 6 inches. So it can kind of pick up on from this drawing is X plus 3 feet 6 inches has to equal the total distance, which is 8 feet 6 inches. And to solve for X, we can just subtract each side by the 6 feet 6 inches. So if I subtract 6 feet 6 inches over here, we end up within 2 feet. So X would be 2 feet. So we can break it into different shapes and solve it. We don't have to, we probably don't need both layouts. We probably could figure that out from layout one. But anyway, we can kind of do it in little pieces. So if I look at this example here, find the number of feet of 4-inch stock needed for the base plates of a room that has a layout shown in our figure. Make no allowances for openings when calculating the linear footage of the base plates. So again, we want to find the number of feet of a 4-inch stock needed for the base plates of a room. So let's see what we got going on here. So notice how it says the number of feet of 4-inch stock. So I think what we're really looking for is we have these base plates. So we're just really just going around the thing. And what we're going around with is these let's see here. Let me pause for a second. So again, as we read through this problem a couple of times, just try and grasp what they're talking about here. Now, remember, rooms do have openings, like doors and stuff like that. So they're ignoring doors because remember, you wouldn't, if you're talking about base plates, we're almost like talking about base trim. 4-inch stock basically means it's probably a 4-inch high base trim. What we're trying to figure out is how many linear feet we need to go around the room. So to find out how many linear feet we need to go around the room, we still need to find these dimensions of this X and Y. So notice how there's this 7 feet here. So notice how I could bring that over. And this 7 feet would be over here. So notice how we can create a rectangle. So we have this rectangle here. So our rectangle would look like that. So going around there. So notice that, if this side over is 15, we know this side's got to be 15 too. So what we're picking up on is then, we have X plus 7 has to equal that same thing as 15. So if we subtract 7 on both sides, we'd end up with X equals then 8 feet. So this missing dimension would be 8 feet. So let me get my eraser out here. We found one of those missing dimensions. Now we need to still find the Y. Notice how Y is a horizontal distance. So if Y is a horizontal, we're really referring this with respect to the down here we have this 24. And notice that the 9 and the Y would create the 24. So we're picking up on this Y plus 9 feet has to equal this 24 feet. So if I subtract 9 on both sides, Y would equal this 24 minus 9, which would be looks like what, 15? 15 plus 9 would be 24. So if I want to find out how much feet we need all together, I'd have to add all those numbers together. So we'd have this 15 here. So to find our answer, our total perimeter would be then this 7 plus this 24 plus 15 plus 15 plus the 8 plus the 9, and now we're back around. So, 7 and 24 would be 31, 15 and 15 would be 30, 8 and 7 would be 17. So then we would have, 61 plus 17, that would be 78 feet of baseboard would be needed. So again, we wouldn't really need actually 78 feet, but we would need close to that to actually do the job. But so they kind of, again, they said make no allowances for openings. So we were going to go straight through without openings. So that's how we would do a problem like that. So again, vertical dimensions will go with vertical dimensions. So the 15 and the 7 and the X kind of go together. And the horizontal dimensions go together. The 24, the 9, and the Y go together as well. So you can kind of pick up on that pattern. So the thing we got going on is what's called area of shapes. Remember, the area is how many squares are inside of a shape. So we have all these different formulas that we can use to find the area of these different shapes. An interesting one, though, is for a triangle, most of us are familiar with 1/2 base times height, but we may not be familiar with Heron's formula. So that one's a different one. So S times S minus A times S minus B times S minus C, where S is going to be A plus B plus C, and you take half of it. So it's a different kind of formula to find the area of a triangle. So if I want to find the area of a triangle, we can just simply use this formula, 1/2 base times height. But remember, the height has to be the distance from the base to the top of the triangle. So notice in our example, here's our base here, and the height is going to be from the base to the top. And it looks like they gave that to us as well. So our formula is going to be 1/2 base times the height. So it's going to be 1/2 times 8 times 6. So for me, I could take half of 8, and that would be like 4, and 4 times 6 would be then this 24. But remember, area is the number of squares. So the unit measurement for area is going to be inches squared, or we would call that square inches. So if I want to find the area of this triangle using Heron's formula, we don't actually have to know the height. So Heron's formula says, to start with, we need to know what S is. S is going to be 1/2 A plus B plus C. So S is going to be then 1/2 of 19 plus 15 plus 8. So S is going to equal 1/2 of 19 plus 15 would be 34 plus 8. So S would equal 1/2 of 42. So S would equal actually a 21. So Heron's formula says to find the area, we take the square root of S times S minus A times S minus B times S minus C, if I recall that correctly. We'll double check ourselves here. I don't use Heron's formula much myself, but yeah, S times S minus A times S minus B times S minus C. And Heron's pronounced different ways there. So if I want to find the area using Heron's formula, it would be then the square root of S is 21, and then we have 21 minus A. A is usually denoted as the side opposite of angle A. So this would usually be denoted as A. If we have angle B, the opposite side would be labeled B. And if we have angle C up here, C would actually be this 8. Again, it really doesn't matter who's who in our formula, but that's kind of how this works when you have angles and sides. So if we have angle A, the side opposite of angle A is side A. So we have 21 minus then 15 times then 21 minus 19 times then 21 minus 8. Now, instead of doing all this math here, or can we do this math? Don't look that bad. Let's see here. Area equals the square root of 21 times, then 21 minus 15 would just be 6. 21 minus 19 would be, what, 2? And 21 minus 8 would be 3. So what we're seeing here is we'd have area equals then 21 times 6 times 6. So that's going to be, area is going to be 21 times 36. So looks like from there, it does say round to the nearest hundredth. So we're going to have to go ahead and do that because that's not going to be a perfect square. So let's see if I can slide this over here, use our calculator. So we have the second button, square root 21 times 36. And that gives us then 27.495. So the area would actually be So is it going to be 27 point? Oops. Let me try that again. Get this out of the way. So we have 27. Let's see here. Quick moving on me. I don't know what happened there. We just took off on me. Let's see. Trying to get my little green pen to work again. So we have this 27 point. And based on our rounding, we have to round to the nearest hundredth, which would be where the 9 is. But that 5 would say round up the 9 up. So that means that 49 is actually got to change to 50. So 27.50. And since we're talking, do they give us any unit of measurement? So that it actually gives a unit of measurement. So we just leave that as 27.50 square units. So another thing they may give us is these composite shapes. So if I want to find the number of square yards of carpeting required in a room, what we can do here is look at this shape here is we can divide it into shapes. So one way I can do it is kind of break it off like they did here, is cut it into the shape here. That's kind of what they did. So we have this rectangle and this rectangle. So if we can find the area of this rectangle and find the area of this rectangle, that's going to be our total area. So in other words, they're saying if I find the area of A, find the area of B, add those together, that'll be our total area. So to find the area of our shape, it's going to be 9 times 7 to start with for that rectangle, plus 10, and this is going to be a 15 by 15 rectangle. So 9 times 7 would be 63. 15 by 15 is 225. So then we have 63 plus 225. Or again, if you want, you can just type in 9 times 7 plus 15 times 15 into the calculator, since we're going to use it anyway. So we'd have then 288 as our final area. And since they put this in feet, this would be then in square feet, would be our total area of that shape. So another thing we have is these irregular shapes. So if I want to find the area of the gable end of a gabriel roof that has dimensions as shown, it looks like the side of a barn. So if I want to actually find the area of this, notice how we can kind of partition this top off like so. And what I can do is create 2 triangles, if you will. So see if we can kind of piece that together. So notice how this dimension kind of goes up here and this dimension kind of goes up here. So this means this is like 23 here. And notice how the height is actually 5 feet 4 inches. Now remember, in multiplication, we can't have mixed units. We have to be under the same unit. So let's put our thing in terms of, it's usually easier to go in terms of inches, but let's see here if we can just go ahead and just change 4 inches into feet. So 4 inches, if I want to multiply that by the conversion factor, we know that there's 12 inches, so that's got to go on the bottom per 1 foot. So essentially what we got to do is divide by 12 to convert inches into feet. That makes sense. So 4 divided by 12, this is going to give us this 0.333. So I hate to round this early in the game, so we may want to just leave that as, yeah, we're going to have to do that. Yeah, I don't like to round early, but we may have to do that anyway. So we have that shape there. But notice how, if I want to find the area of the triangle, it's going to be area equals 1/2 base times height. So we have 1/2. The base is going to be the 23. But the height's not going to be 5 feet 4 inches. It's going to be like 5 feet 0.33. So let's carry that out like 4 decimal places so we can get a little bit more accurate. So if I clear that off, so 1/2 is like 0.5 times then 23 times then 5.3333. That'll give us a more accurate answer there. So let's just leave it like that for the time being. Let's not round too much until the very end. So let's say we have like 61.33295. So then notice that the other shape is actually going to be a trapezoid. So notice how the base is going to be 3 plus 23, which is 26. The base is going to be 29. Notice that the height is given to us as this, this height's given to us as this 8 feet. So we have 29, 23, and this 8 feet. So to find the area of the trapezoid, our formula is going to be area equals 1/2 times the height times B1 plus B2. So let's see, I think that's how they wrote it. So find the area of a trapezoid, 1/2 times the height times B1 plus B2. So our height in our problem is the 8. So we have area equals 1/2 times the 8. And then B1 plus B2 was the 23 plus the 29. So if we follow the order of operations, we can add 23 plus 29 to begin with. So we have 1/2 times 8. And then 23 plus 29 would be, is that like 52? So 52. So then we would have like half of 8 would be 4. So what we're down to is 4 times 52. So if we want to multiply 4 times 52 on our calculator, that would give us then 208. So the area of our shape there is going to be then this 208, and this is going to be square feet. So that's going to be that space, one of the sides, like it's like on a barn, gable end of a barn, gable roof is what they call it. But I've seen that shape before, and we can actually find the area of that by doing what we call composites. That actually turns into a triangle and a trapezoid. Okay, so that's a little bit on polygons. So we have perimeter and area. Remember, perimeter is going to be the distance around an object, and the area is going to be how many square units are inside the object.